but hello, everybody, and welcome. Good afternoon. I'm Dr. Deanna Minich, and we are featuring, as you know, the American Nutrition Association is featuring a number of thought leader conversations. Today, we have Dr. Michael Snyder. He is the Stanford Asherman Professor and Chair of Genetics and the Director of Stanford's Center of Genomics and Personalized Medicine. Dr. Snyder received his PhD training at the California Institute of Technology and carried out postdoctoral training at Stanford. He is a leader in the field of functional genomics and proteomics and one of the major participants of the ENCODE project. His laboratory study was the first to perform a large-scale functional genomics project in any organism and has developed many technologies in genomics and proteomics. He's the author of the book, Genomics and Personalized Medicine, What Everyone Needs to Know. So welcome, Dr. Snyder.
Thanks for having me here.
Wow, we got you on your Friday afternoon, or actually midweek afternoon, and I know you're busy. You're busy with studies, and so thank you for being able to do this and making some time for us.
My pleasure.
Can you tell us, I'm just curious how personally COVID-19, this whole pandemic, has affected your life. So what have you seen? I know that you're into wearables, into technology. You probably have been assessing your own metrics as you've moved through this pandemic. What have you noted for yourself?
Okay, well, so maybe to back up a little bit, as you probably know, we measure me a lot on all kinds of things. And normally I travel a lot, so it's affected my life in one big way, like all of us, which means I'm at home with my family, so they're not terribly used to seeing me, so that part's pretty new. But as far as my research, yeah, we're into collecting big data to try and better manage people's health. And so specifically, we do deep blood profiling on people. We sequence people's DNA. We try and predict things that they're at risk for, and then try and catch disease at its earliest possible moment. So that's what my laboratory does. We've spun off companies around this sort of big data and health kinds of companies. But I think specifically as far as how all our research impacts COVID-19, probably the area that's the most impactful is the wearables. So what we do is we tend to measure, let me back up a little bit. So we've been collecting all kinds of, say, biochemical data from people's blood and urine initially, but then when these smartwatches came out, they're mostly being used as fitness trackers. And this even before the Apple Watch, we realized that actually these are pretty good physiological monitors. So we could start using these maybe to track people's health, and let's see what we can learn about them. So I've gone out and tested many. Our lab has probably 50 of these devices. There's over 900 of them on the market of smartwatches and all kinds of portable devices. And so we've narrowed it down to 8 devices that I use every day. I'm wearing 3 smartwatches right here. This ring is not really a ring, it's a tracker. Continuous glucose monitors, all kinds of things I use to track myself. And so I've been doing this for a long time, and it's been very powerful. I actually first figured out when I got Lyme disease because my blood oxygen dropped, my heart rate went up. So the way this actually relates to COVID-19 is we had a study going where we were basically tracking people with smartwatches and suddenly realized that, well, sort of with the Lyme disease story I told you about, that we figured out from a drop in blood oxygen, an increase in heart rate, that we could detect people's disease actually even before they're symptomatic. And that's what happened for me. My first, these measurements first alerted me. And the way they do that is that they collect so many data points on you, like continuously, so that they're measuring you all the time. So it's very, very easy to see if you shift in your heart rate or you shift in your skin temperature, you shift in your blood oxygen, these devices can pick it up. Mm-hmm. So that's what happened for me in Lyme disease. And then we went back and looked at all the times I was sick. I'd been wearing the watch 4 times. And this is really very, very important. But of the 4 times, 1 was Lyme disease, 2 were viral infections, and the 4th time I was sick because I had a blood marker that was very elevated, but I didn't know it. And every single time I could see my heart rate went up, and actually my skin temperature went up as well. So we've written an algorithm that can actually tell you when you're getting sick, we think, before you realize it, because your heart rate goes up. We call it change of heart, and you can get it right from your smartwatch. And so the idea, go ahead.
No, how fascinating. So,
It works not only on me, but we showed retrospectively it worked on actually 3 other people, one of whom got sick twice. So in every single case, before the person actually realized they were symptomatic, or maybe at the very first time, but probably before, we actually could pick up this change of resting heart rate. And so,
does this happen for pretty much all types of sicknesses, or are there certain ones? I know that you tracked yourself with Lyme disease, also with diabetes and looking at blood sugar, but could we say this about just any acute or chronic illness?
the signatures are going to be different. So the diabetes signature we picked up is not as strong as, say, the viral infection or the Lyme disease ones. So that's a very different set of measurements. So yeah, I think we can tell that a bit differently. It's not as sensitive as, say, the viral infections.
Okay.
But we think we can tell the difference between Lyme disease, for example, or bacterial infections, I should say, and viral infections, because the signatures are quite a bit different too from the devices, what they pick up. They're much, much stronger with a bacterial infection. And the nature of them is a little bit different. So what we're trying to do now is a couple things. One is the smartwatches are a lot better than when we ran that first study. So they'll measure many, many more things and more accurately. So what we're doing now is we're setting out a big study. We're enrolling you. So I'd love to have all the listeners sign up. It's a 2-part study. What we're doing initially is we're actually collecting people's data. We'd love to get you, we'll take anybody, but we would love to get you if you've already been ill with COVID-19 or actually any illness. It would be great if you signed up for your study and let us know when you got ill, and then we can tell. The first thing we're going to do is retrain our algorithms, make sure we can see COVID-19, which I'm pretty sure we can because of some preliminary data we've done already. What we don't know is how good it works. Like, can we pick up people who are asymptomatic or not? I'm hopeful we can, but I don't know for sure we can. Why am I hopeful? Because of that one time I didn't have symptoms, but I could still pick it up with my smartwatch.
Yeah.
So go ahead.
And what about after post-illness? How long can you see that in metrics until somebody is completely resolved in their physiological markers?
Oh, I think when they go back. Yeah, I think when they go back to normal, when you finally cleared it, your heart rate goes down pretty much to normal, and that's true. Now, some people will get a secondary bacterial infection and things, and they won't go back to normal, but in general, you probably will. So what's powerful about these then is that these devices will actually, they're used widely, as you probably know. So 30 million people are actively using Fitbits, for example, and tens of millions on Apple Watches. So what we hope is that in the first part of the study, we train our algorithms, get them perfect, or as best we can, should say. And then the second part of the study is to really try and tell you when we think you're getting sick. So if we see that a heart rate's going up and your skin temperature is elevating, we'll send an alert. That's the second part we'd like to do once our algorithms are trained once again. And we would say, well, look, we think, something's not quite right here. This is going up. And if you're watching a scary movie or something like that, you just ignore it. But if you're sitting around, on a couch, not doing much, and suddenly your heart rate seems a lot higher, then maybe there is something going on, and maybe you shouldn't go to work that day, for example, or come in contact with others. That's the idea.
So it would seem like that metric needs a context. It's not just if your heart rate goes up that there needs to be an alert. You have to look at why that might be. There might be a good reason for it. It might be transient.
Right.
Yeah.
We can train some of that, we think. For example, if you're running and your heart rate's up, we'll know that because these have what's called an accelerometer. They're measuring your movement. So that one we can tell pretty easily. But if you're just sitting around, we can't always tell what you're doing. And so you will have to contextualize the information.
Okay, great. And I'm curious, so you said that you are wearing 8 different devices right now, 8 different monitors. Can you tell us what they are?
Yeah, well, one is this is a Fitbit Ionic. This one's a BioStrap. It's starting to fall apart, so I better fix it up a little bit. That's my Apple Watch. This is an Oura Ring. So these are all, on your wrists or your fingers, and they measure, your movements. They'll measure your heart rate. They're all pretty good for heart rate, by the way. Heart rate measurements are really quite accurate with these devices, probably better than what you get in a doctor's office, because what you get in a doctor's office is all over the map, depending what you've been doing. Like if you ran there or biked there versus if you drove, or depending on your stress level. So these are much, much more accurate.
Mhm.
I also have a continuous glucose monitor I wear pretty routinely. I have other apps on my smartphone. By the way, all the information, we've now built a dashboard that pulls all the information into your smartphone so you can actually display it and see it. What else do I use? I use a radiation monitor a lot, so I can tell radiation levels, which is usually pretty boring, but gets interesting every now and then.
What do you find with that? Where do you tend to see peaks in certain places of your home when you travel, when you're out in the sunlight?
No, it's more high energy radiation. So when you go up in an airplane, you'll get about a 15-fold higher exposure to high level radiation than you will if you're sitting down here on, planet Earth. um,
Mhm.
where else does it? But it did show very interesting once when I was in a hospital where they treat patients. And I was at a cafe and someone walked in, or actually I should say we walked in, a friend of mine, very, very small cafe, and the thing buzzed off the roof. It went 800-fold higher. And it turns out I have a pretty good idea who it was, that there was an individual in there probably getting some sort of radiation therapy or diagnostic. So that taught me you probably want to keep your distance from someone who's getting these therapies because it's pretty high, actually, what was measured. And I'm pretty sure it was somebody there. I went back to the cafe twice later, and sure enough, it was back to normal levels. So it was definitely somebody who was in that small cafe.
That's
So
fascinating.
that was an unusual one. But we've seen some other locations that'll be up a couple of fold higher than you would expect. I don't think any of that's dangerous, but it's sometimes amusing.
Yeah, but it all can tell us a pattern about our health, right? So if we see heart rates going up, radiation is up, if we look at multiple markers, then maybe it's telling us that there can be some issue.
Yeah, we think so. So the wearables are very convenient. We think the blood sampling we do, so going back to the bigger picture, where we'll literally measure thousands, if not many hundreds of thousands of molecules in your blood and urine. The combination of all this is very, very powerful for, defining and evaluating how healthy you are. And then
Mhm.
again, you can see these shifts when people become unhealthy. And the goal is to catch it very, very early before they become symptomatic. So we really want to catch disease at its earliest possible time when you can manage it really well. If you wait till things get very late, it's very, very hard to reverse. Cancer is a great example, right? Where if cancer comes on very late and it spreads, then it's almost impossible to actually cure.
Have you actually been able to monitor the onset of cancers of various types with
We
wearables?
did actually in our study. So the first study we did had 109 people, and from about a little bit over 3 years of profiling, we found 49 major health discoveries. It was an older group of people, meaning the median age was 53.4. But what happened was we caught some with early lymphoma, two people with precancers. They have technical names, but they're very early stages of cancer called MGUS and other things. And you monitor those folks closer. Two people with serious heart issues were caught, one by sequencing their DNA, another from a wearable, actually.
Hmm.
All kinds of different things. We had found two people were diabetic who had no idea. And then we caught other people as they were becoming diabetic. So we've caught quite a few different things, again, at very, very early times when they could be managed. And we found people with plaques in their arteries, things like that from imaging scans. So we think this deep data profiling, I know it tends to scare physicians a lot, but we think in the future it's just going to be, our goal is to make it a routine part of healthcare. And so that's what we'd
Absolutely.
like to do.
Yeah, and to have it be continuous rather than just a snapshot, like a lab marker, right? So we can actually see diurnal patterns or, just continuous glucose monitor just seems to be so valuable for people so that they can see how sleep affects their glucose, how different foods. I'm curious about food. Since we're doing this for the American Nutrition Association,
Mhm.
I don't know if you can speak to anything from a diet perspective. Are there certain ways of eating or when people are eating that affect these metrics, these different wearables?
Yeah, well, certainly the most powerful is the one you talked about, the continuous glucose monitor. So I've been wearing one of those for about 8 years now, and I know exactly. I'm type 2 diabetic, which I first predicted from my genome and then caught while I was doing this various tracking of myself. And for the continuous glucose monitors, they're very, very powerful because if you're wearing one of these things and you see how food spikes you. So let me back up a little bit. You probably know that 9% of the population is type 2 diabetic, and about 30 some percent, probably about 33% are pre-diabetic, and 90% of those have no idea. And 70% of those are going to become diabetic.
Mm-hmm.
So there's a huge fraction of the population that's pre-diabetic that will become diabetic and they have no idea. And these continuous glucose monitors are very powerful for A, identifying these people, B, seeing what spikes their glucose. And if you wear one of these devices, you'd be amazed at what spikes you. And it varies from one person to the next. That is, some people spike to pasta, others to bread. And it's thought, again, that I'm not sure how much your readers follow, or your viewers follow this, but your microbiome is a key part of that. So the microbes in your gut are very important for what you digest, and they vary from one person to the next. So it's a big deal to actually see what spikes you, and then you can avoid those foods, avoid the bad foods and eat the good foods. And these CGM monitors, as they're called, are just super powerful for that.
Mm-hmm. Wow, that is so fascinating. It's amazing to think that just one metric can give us so much information, just like in that moment. I'm curious about toxic exposures. Since
Okay.
we know that environmental medicine is really, it's something that people are looking at and exploring, and now starting to look at toxic burden, the exposome. How are we able to assess toxic load through wearables? Are we?
Well, as you may know, you hit a nice subject that we've just also started working on. So we're really big on collecting all kinds of data that might impact people's health. And so also about 7 years ago, we built something called a personal exposometer, an air monitor that measures airborne exposures. And unfortunately, I don't have mine in my room. It's always right next to me. I actually forgot. It's out in the kitchen there. But I normally have it right next to me, and it's a small portable device. And what it does is it sucks up air, roughly about 1/7. The latest version sucks up about 1/7 of what you breathe. And under the pump, it'll measure all the standard things. It measures something called PM 2.5, so particulates, measures temperature, humidity. But one of the coolest things that we did was we re-engineered it. So under the pump intake, under the filter intake, we have a filter that captures all the particulates. And under that, we have a chemical absorbent. So we'll run this thing for a week. I use one during the weekday, one during the weekend, and one every time I'm in a new location, like in Germany or Asia, where have you. I'll always have a different device for a different location. And what we can do is for the filter, we can measure all the biologicals you're exposed to, your pollen, bacteria, fungi, everything you're exposed to. We'd like to set it up in a way that we could start measuring viruses. We tried that. It actually didn't work the way we're doing it. So we have ideas how to make that work now. But then we can measure COVID-19, which would be pretty powerful. And then we measure the chemicals by eluting those off and actually doing something called mass spectrometry. So we can measure all the chemicals and all the biologicals you're exposed to. And if you think about it, where you're sitting right now, you have no idea what you're exposed to. Nobody does. But with these devices, again, they're pretty eye-opening. You'll see DEET, the stuff you use to keep insects off you. It's everywhere. Pesticides are everywhere, but they're more in some locations than others, which we've seen. Certain carcinogens are everywhere. Plastics are everywhere. Again, but their location will vary quite a bit. And
do you think that knowing this could really create a lot of fear in people, however? So if you're metricizing your entire environment and you have no control over your environment, I mean, how do people actually emotionally and mentally reconcile that? Do you think that could be difficult for some people? Or can we use wearables where we get information where we can actually change it?
Yeah, well, I think that's the goal, to change it. If you are in a toxic environment, maybe you should know that. Ignorance is not always bliss. Ignorance could kill you. So yeah, imagine you're in a spot right now where you're getting exposed to some nasty carcinogen. Again, you would have no idea if that's happening because you've probably never measured that. Maybe you want to know that. And there are remediation efforts you could take depending on what it is. You could put air filters, for example, in your room and actually start sucking those things out. So it is true that you need a remediation strategy to go with this. And so information that's not actionable can be distressing to some people. And so I think you want to manage it accordingly, but I think it's up to the person to decide what information they'd like to collect.
Yeah. I just came across a paper not too long ago on smart clothing. It was all about smart clothing. Then there are smart toilets, how we can be looking at what's in the stool, how we can be wearing clothing that monitors temperature change in various areas, and that gives us correlational information.
Mm-hmm.
So beyond wearables, it sounds like, right now we're with small devices. How do you see this getting larger and larger into having a smart home, having a smart refrigerator? How far will we go with all of these wearables and different smart technologies?
Oh, we're going to go a long ways, and they can be used, hopefully for good, hopefully not for bad. But a good example of good is maybe once you've eaten a certain amount, maybe your freezer locks, but in a personal way. Maybe it locks for you because you've eaten too much, but not for someone else in the house that, hasn't eaten their amount.
Wow, that sheds a whole new light on emotional eating.
Yeah. But think about it too. There's a lot of people who are, whose health may not be so great. Like your older parents, you'd like to take care of. My mom passed away, but before she did, she lived to be 91, and she was 3,000 miles away on the East Coast. And I really wanted to have a smartwatch on her so I could just check up on her every now and then, see how she was doing, because every now and then she would leave the phone off the hook. And all of her kids, I'm one of 6, everybody would scramble to figure out, is mom okay? Is mom okay? So they'd call the front desk, who would then go up and check on her. She was it's independent living, but there was still someone to keep an eye out. And if I just had her a smartwatch on her, I could just look on my computer and say, oh, she's fine. Everything's good. Don't worry about it.
You're right. There's utility there. It can really be functional. I have this vision where I have my smartphone, I connect it to, I turn on the light, I get some kind of sensor with my glucose, I go to the grocery store, I'm scanning food for their nutrient density. I mean, so much information truly could be taken in and synthesized to give us better decisions in the moment.
Absolutely. The grocery store is a good example. I have it when you scan it. Yeah, maybe it will tell you, you don't really want this, given, you're going to spike to pasta. Why don't you go over to the bread section and get that instead if you don't spike to that? That's a great example.
Yeah, and plus our physiology is changing so rapidly. So we might be so different day to day, even with our microbiome. So we can't always account for our blood glucose being that sole factor. It might be interesting to look at a compilation. And I know different groups like yours are working on algorithms.
We want to predict people's personal trajectories, meaning if you are starting to go off in your diabetes or some, your cardiac markers, for example, apolipoproteins, that kind of stuff, you'd like to track that and follow people's personal trajectories, and then have an automated system that feeds back and says, first of all, you should get measured more frequently for those so you can keep an eye on it, and B, maybe you should be eating these things and not those things. So again, you better manage your health. And so, but by the way, your microbiome doesn't change as much as you think it does. It's pretty stable unless you start doing dramatic things to it. Like really.
But with so many people making dietary shifts and going from keto to paleo and, doing radical cleanses of various types, I just wonder how much all of that can.
Those will shift you, yeah. They will, yeah. So if you do something radical, it'll do it. But for most people, maintain pretty much the same eating habits and things. They stay pretty constant, even over years. But if you do something a major shift, like you're saying, change your diet to keto or paleo, yeah, you'll probably shift it. It'll take a little time.
Stress. I would think, you have a bout of stress, like something happens, a loved one dies, you lose a job. Especially now, I think of within this pandemic, there are so many different factors that are changing for all of us, and how our microbiomes could be changing.
I think that's true, yeah. And I think probably other factors as well, like there's something called your epigenome in states like that. It's well known that you may know this, but nutrition can affect the way your DNA gets modified, which affects your genes getting expressed. So we think, and people don't really understand how this works. Exercise does that as well. Again, in a very beneficial fashion. We don't, same thing, really understand how this works. But that's part of the goal of our research and that of many others as well.
Well, I'll just put my vote in as a PhD nutrition researcher. What I would like is if there's some way to assess nutrient status, because I think that many of the tests out there are imperfect. And it would be nice to know, how's my zinc today? Do I need more zinc? What about my zinc to copper ratio? What about my omega-3s? Can I just do that with quick wearables rather than be sending in blood samples or, make a doctor's visit? It'd be very interesting to have this morph into more of a nutrition focus. I think that could better help us with supplementation, with dietary changes. It's fascinating to me.
Yeah, I totally agree. And there's no reason not to. You mentioned the smart toilet. That's trying to measure a few things. But in the future, as these technologies get more and more advanced, you should be able to measure thousands of things. And that's part of our goal, to really get as much information as possible. So again, you can make the best decisions about your health. And nobody's going to take as much charge of your health as you.
That's true.
Right? Because a physician has 15 minutes to spend with you in their office. And you have a lot of time compared to them. And so you should be able to make much, much better recommendations for yourself than they ever will be. So I think in the future, your smartphone is going to be your most important health instrument of the future. So
yeah, and as I've heard before, if you don't measure it, you won't change it.
That's correct.
So having that constant feedback, that biofeedback coming back, and it's like, okay, course correct. And you can quickly course correct rather than wait years to course correct. So it speaks to your preclinical diagnosis and really getting in there early rather than late.
Yeah, the goal is to keep people healthy rather than treat them when they get sick. That's our mantra. We want to do healthcare, not sick care.
Yes, that's really where we're aiming. How can we find out about your study? I'd like to know more about how we can register, find out more, look at a website.
Yeah. So for the Wearables infectious disease study, the COVID-19 one, you can visit a website called innovations.stanford.edu. So innovations.stanford.edu and sign up. We'd love to have you, again, especially if you've been sick. You'll help us train our algorithms. And the goal literally is in 2 weeks to come back with a trained algorithm and start getting this out to millions of people. That's what we'd like to do. I don't know if we'll pull it off, but that's what we're trying. People are really working around the clock on this. And then we have other studies. They're hard to run right now because we're in shelter in place. But once we come out of that, visit our lab website. That's the Snyder lab. You can find it pretty easily. And we run continuous glucose monitoring studies, all kinds of different studies in this whole space. And you might find them fun to participate in.
Absolutely. I'm intrigued. I definitely feel like this is the wave of the future. And as we talk about at the American Nutrition Association, it's all about personalization. And what helps us be better in touch with that, it's these wearables, really being on the pulse of how we are moment by moment and looking at these patterns. So It's been a pleasure.
Pleasure's been mine.
Yeah, this is so fascinating. And I know you have some time constraints, and we're very fortunate to get you for this short duration. So thank you, Dr. Snyder. And I just want to close by saying that the ANA is a professional home for the science and practice of personalized nutrition. If you're enjoying this interview series, you can find all the recordings on their website and get more great content by becoming a member of the ANA. You can learn more at theana.org. Thanks, everybody. Have a good rest of your day. Bye-bye.